Welcome to Mac 2311 for Engineers, Exam 4, problem number 3. In this question, they go ahead and they ask you to take the derivative with respect to x of this integral, which is in terms of t. So whenever you see this expression where you're deriving an integral, so you have to do both of them, you don't actually have to go ahead and integrate this first and then differentiate it. This is going ahead and exploit the idea of the fundamental theorem of calculus, where you know the derivative and the integral are actually opposites of each other. You can think of them as rungs on a ladder. When you go ahead and you derive, it takes you up the ladder, but when you integrate, it takes you back down. So if we integrate this and then differentiate it, we'll end up with the exact same function, almost. So, because what's going to happen is when you integrate this, you'll get some newly created function, and then you have to go ahead and evaluate it and do top minus bottom. So what happens is you're going to go ahead and have this new function with this plugged into it, and with this plugged into it. And then when you go ahead and derive it, that newly created function will return back to this function, because that's what you integrate to get there, but then you have to do a chain rule to it, and therefore you're going to actually end up multiplying by the derivative of these bounds here. So essentially, the rule is, if you have a derivative of an integral with these bounds, then it's just going to be, you plug the top bound into this expression and multiply it by the derivative of the top bound. Then subtract it from the original expression with the bottom bound plugged in times the derivative of the bottom bound. So if you want to go ahead and think of this as just f of x, then if you have the derivative of some integral from a to b of some function, and we'll actually call it f of t, dt, then that's always going to be equal to f of b times b prime minus f of a times a prime. And a and b here can be constants, but they don't have to be. You can see that this is actually a function. And the thing is, if they actually are constants, then that whole term will go away, because the derivative of a constant is 0. So in this case, the back half is going to actually go away, because a prime would be 0 in this case. So this would just go away, and you only get this section here. So it's nice if you actually see a constant on one of these bounds. So this expression here is actually just equal to 2 square roots of x times ln of 1 plus square root of x. I just went ahead and plugged the top bound into the function here. Then I have to multiply it by the derivative of square root of x, which is going to be 1 over 2 square roots of x. And then you can see that this will perfectly cancel out with that. And you're just going to be left with ln of 1 plus square root of x, which is answer choice E. And that's it.